Katina begins to tear up as she looks at her score. You already know why she's ready to cry. She barely passed the exam. I just don't know why I lose everything when it comes time to take the test, Katina maintains. I understand it fine when I'm at home or in class. It's just that when I see the test, I freeze. I think I suffer from test anxiety, or maybe it's just that I can't do math. My mom says I'm just like her, bad at math. Katina, by all appearances, is a good student. Testing has ruled out obvious challenges such as reading or math disorders, and Katina does her best to focus on what's being taught. She finishes her homework, even if it's sometimes imperfect. She also creates great craft projects and has many friends. In other words, she's creative and the kind of person other students enjoy being around. It's not just Katina's stress with math. Ben has the same problem. And Federico struggles with writing, Jared with Spanish, and Alex with understanding the periodic table. In fact, perhaps a third of your class seems to have already boxed themselves in with an I can't mentality in one subject or another. You worry that when it comes to state-standardized tests, Katina and others like her in the class will pull down the school's average. Downward goes the school's average and the school's morale, and downward goes your morale. What's going on? Can you help Katina, Jared, and the others improve their ability to be successful learners in their seemingly weakest areas? Learning creates links in long-term memory. To understand what's going on, it helps to take a step back and look at the fundamental building block of our brains, the biological cell called a neuron. Each person has about 86 billion neurons. There are plenty of neurons to go around. Even your most challenging students have loads of them. Whenever you or your students learn a new fact, concept, or procedure, you are making new connections between small sets of neurons. Neurons, if you look only at their main parts, are simple. They have legs, which are called dendrites. The legs have lots of spines on them, almost like a cactus. Technically, these are called dendritic spines. And they have an arm, which is called an axon. When students are actively focusing on their learning, they are beginning the process of making connections between neurons. These connections start forming whether students are sitting in front of you in class, reading a book at home, trying out their first layup in basketball, or deciphering the ins and outs of a new computer game. In other words, they are encouraging their axons, neural arms, to reach out and almost touch dendritic spines. Once a neuron involved in the learning process comes close enough to a neighboring neuron, a signal jumps across the narrow gap, called a synapse, between the two neurons. That signal, as it passes from neuron to neuron, is what forms our thoughts. It's the foundation of our learning. For illustration of this concept, refer to page 2 in the downloadable PDF. Learn it, link it. As students are learning, neurons are linking and strengthening. We refer to this process as learn it, link it. This term has its origins in Hebbian learning, a process where neurons that fire together near simultaneously in time wire together. Donald Hebb, a Canadian psychologist, first described this process. In other words, when a certain set of neurons begins to work together more often, they become like a well-practiced choir. Singing together is in fact how neurons form a sequence of links with one another, as shown on page 2 of the included PDF. To get a sense of how the neurons link together, look at the Learn It, Link It panel on page 3 of the included PDF. When a student first starts to learn something, neurons begin to find one another and make connections. We refer to this as the Learn It phase. Actual neurons are laid out in a more complex structure in the neocortex, the evolutionary new area of the brain that helps us do our heavy-duty thinking. But we'll keep things simple here with our neural layout.